3.5 and on Thursday 3.6, and then we'll review next Tuesday and the test will be on Thursday. So that's the plan. That's the plan. And I'll ask you again if everyone is okay with that. Okay, so here's an example of a rational function. Here's another example of a rational function. So what is a rational function? Well, the answer is a ratio of two polynomials. Ratio of two polynomials. So f of x is rational if I have a polynomial at the top and a polynomial at the bottom. This must have x, bless you. Must have x. The top, as you see, does not have to have x. If there is no x in the denominator, the function is not rational. Of course, I still have to see what we are looking at, but if there is no x in the denominator, it's not rational. For example, f of x equals x divided by 2 is not rational. This is a linear function. It's 1/2 times x. So this is linear. A rational function doesn't have to have x at the top, but if it doesn't have x in the denominator, as I said, not rational. I separated all rational functions into 3 categories. Category 1, category 2, category 3. Type 1, type 2, type 3. You will not see them like that, divvied up like that in your book or other books. I had to separate them so that I have a communication with my students and they understand what I'm talking about, because they are different. So I'm going to list a few examples for type 1, a few examples for type 2, and a few examples for type 3, 2 of each. And I want you to tell me why I put these in one category, why I put these in this category, and why are these in that category. The name doesn't matter. I didn't specifically chose these to be type 1. It doesn't matter. Okay? But I want you to tell me, I would like you to tell me why, what do they have in common? So here's f1, x plus 1 over x minus 3. And another example, f2, x squared minus 4 over x squared minus 1. Type 2, an example will be 1 over x. Another example would be x divided by x squared minus 4. And in type 3, 2 examples. Let's say x squared plus 1 divided by x minus 1. And f2, I'm going to say x cubed minus 1 over x squared plus 1. Okay, what do the first 2 in category 1 or type 1, what do they have in common? What do you think? Why did I put them in that category? Is there something that, yes, please, Harry?
Well, it looks like it's more or less almost reflected similarly on the top to the bottom. The numerator and the denominator both have the same exponents. Everything kind of matches up.
Exactly. So degree n over degree n, meaning the same degree. Same degree at the top, same degree at the bottom. That's it. Awesome. Can anyone tell us what do the other 2, next set, have in common? What would you say?
Denominator has a higher degree.
That's it. Degree n, degree higher than n. If the top is 5, the bottom has to be at least 6. It can be 10. It can be 15. But it has to be at least 1 unit higher. Good. Last one. What do you think? What do you notice here? Say it again.
The degree of the numerator
is higher, but exactly by how much higher? Here it doesn't matter. So the top can have degree 5 and the bottom degree 10, as long as it's higher. But here, this is very important. The difference in degrees is exactly 1. That is mandatory. So if this is degree n, this must be n plus 1. This is absolutely mandatory. Say it again.
You say N or M.
Choose the same letter, whatever it is. If you want to use mm, use mm. If you want to use nn, use nn. Normally degrees is denoted by n, but it can be anything you want, as long as you understand the difference among these 3 categories. Any questions? Any questions? Okay, so we're talking about graphing rational functions. And we are going to look at all 3 of them. And let's start with a list. We have a long list of requirements, like we had with polynomials, and more. There are things that polynomials don't have. Okay, here's the list that we have to go through. And if you remember, like last time with polynomials, the first problem will take 10 minutes, the next one 3, and the next one 1. Right? So I need to talk a lot about this when we graph the first function. Of course, domain. Number 2, x-intercepts. And of course, multiplicities. Multiplicities tell us a lot. Tell us whether the function is turning there or crossing, and how it's turning and how it's crossing. Yes. Okay, number 3. Yes, of course, Y-intercept. Number 4, of course, max min. Number 5, symmetry. Number 6, range. Now the next 4 are totally new. 7, 8, 9, and 10, all these are new. Yes, Damon, any questions?
Nope.
Okay. Vertical asymptote or asymptotes, behavior near, I'm going to call the vertical asymptote VA. Behavior near VA or VAs. Number 9, horizontal asymptote. I'm going to put in parentheses or slant asymptote. And the last one, end behavior. And you could say, wait a minute, we've done end behavior before. This is not new. True, we have for polynomials and for linear functions as well, which is also a polynomial, special case. But this is a little bit different. A little bit different. Now, I have to mention the fact that these 2 should go together, as well as these 2 should go together. So if you want to say, well, my step 7 is these 2, and then my step 8 is these 2, I'm fine. They do go together. So we're going to go through all these steps. I'm going to start with a type 1. Here's a type 1. Let's say f of x equals x minus 1. I'm going to say 2x minus 4 over x plus 2. Okay. like before with polynomials, I'm going to get my chart going. And I will put all the information in my chart, all summarized in there. Okay, so I'm going back to my list. That's the first time. As I said, the first time will take a little bit longer. Where do I start? I'm asked to graph this function. Where is my starting point? Every time I'm asked to graph, where will my starting point be? Very good, domain indeed. So let's look at this function. Can anyone give us the domain? One more time. Let's try again. The denominator has x plus 2, of course. So then, two plus 2 is not 0.
Wouldn't it be bracket?
No brackets whatsoever. No brackets whatsoever. Because I have to exclude something. If I use a bracket, I'm not excluding it.
X can't equal -2.
Of course. Yes, x cannot equal -2 because -2 plus 2 will be 0 and division by 0 doesn't exist. Yes, so -infinity to -2, 0 has to be in the chart. And what do I write under -2? The answer is nothing. Nothing, exactly, nothing. I cannot write anything under -2. Good. Perfect. So for now, I have this. I know the domain of this function. It's anything but -2. And I explained it. I don't have to write it one more time. This is there. It's very clear to me. If you write something like this, I'm fine. I know that you know that this function is undefined at -2. Do we agree with this? Yes? Okay, perfect. Now, what happens when a function is undefined? A function like this one, a rational function, is undefined at -2. There is a vertical line at -2 that the function cannot cross because the function doesn't exist there. This vertical line is called a vertical asymptote. So once I establish that -2 is a value that the function is undefined at, and I put this symbol, or undefined, I will write immediately that x equals -2 is a VA. So if a rational function is undefined at an x value or more than 1, in this problem, this function is undefined only at x equals -2. At that point, the function has a vertical asymptote. What does that mean? Further, it means this, that the function, the behavior of the function, left and right of this line, vertical line, one option. Both sides of the function will go to infinity. Here's a second option. Both sides, left and right, go to -infinity, approaching this asymptote closer and closer without touching it, closer and closer. What is the third option? On this side, it goes to +infinity. On this side, it goes to -infinity. Fourth option. On this side goes to +infinity, and on this side goes to -infinity. So if I say to you, there is a vertical asymptote at -2, you should say, oh, it means that this side and this side will be infinity for sure, but I don't know the sign yet. It could be both positive, it could be both negative, one positive, one negative. And I would have to establish that right away. Okay, so what did we accomplish so far? We accomplished this by identifying the vertical asymptote. And in a moment, I will identify the behavior near the vertical asymptote, which means one of the four options. Positive, positive, infinity, negative, negative, infinity, positive, negative, negative, positive.
Wait a second.
Yes.
One question. Will we always be able to identify number 7 and number 8 once the domain has been
Yes.
figured out the domain?
Yes.
Okay.
Yes. But I also have to give another example so you can see something else. So the answer is yes, comma, I have to show you one more thing
Okay.
to be accurate. Okay, so how will I establish the sign left and right? Very easy. I will pick a number because I cannot plug in -2 in this function. I will pick a number to the left as close as possible. Notice that it's up there. I'm not going to use it to plot anything, but I need it to find the sign. And -1.9. So with this function, first, of course, I will factor out a 2, and I have x minus 2 over x plus 2. And now I will plug in top and bottom in x, replace x by -2.1, just to establish the sign of this. So -2 minus 2.1 minus 2. What is the sign of the top? Negative. -2 plus 0.1 plus 2. What is the sign of the bottom? -2.1 plus 2. Good. So the top is negative, the bottom is negative. What is the sign of this infinity? Negative divided by negative is positive. Very good. Let's plug in -1.9. -1.9 minus 2. Sign. Very good. -1.9 plus 2.
Positive.
Oh, positive.
And negative of a positive is?
Negative.
That's it. So I already have domain, vertical asymptotes, behavior, the behavior near vertical asymptotes. Okay. Now the x-intercept. How do I find the x-intercept for any function? What do I have to perform? What calculations I perform? How do I find the x-intercept? No, that's not the x-intercept.
I equals 0.
Very good. So 2x minus 2 over x plus 2 equals 0. When is a fraction 0? When is a fraction 0? Of course, when the top is 0. When is the top 0 for this function?
The x.
Equals?
0.
No, 0 minus 2 is not 0.
Oh, -2.
-2 minus 2 is not 0. 2, indeed. When x is 2, y is 0. A fraction is 0 when the top is 0. The top is x minus 2. When I set it equal to 0, I get 2. Agreed? Everyone? Please say yes or no so I know that you're... I'm sorry?
No.
So we are not in an agreement that x minus 2 is 0 when x is 2? Are we now?
Oh, I see it. I see what you're saying.
We are? Okay, perfect. So now I need, so we completed the x-intercept. Since it's a 1 multiplicity 1, I know what's going to happen there. Now I want the y-intercept. How do I determine the y-intercept? Correct. So the y-intercept, I have to find f of 0. Good. So please tell me what is f of 0. Very good. So -2. Any questions? Any questions? Kelsey, go ahead. Any questions? Okay. Are we? Yes?
I don't want to take it back too far, but when you hit the 2.1 and 1.9, when you went up there, how'd you pull those numbers?
As close as possible to -2.
As close as possible.
Yes, as close as possible. You can say there is a number closer to it than -2.1. I would agree. -2.000001. But we don't have to go to, yep. Are we okay so far? Okay, perfect. So max min, this will be with a graphing calculator. Symmetry, a function with a vertical asymptote at -2 will not be symmetric. But remember the two possibilities for symmetry. F of -x equals f of x. What type of symmetry is that? Very good. And f of -x, what is the other option? Negative f of x, odd. Negative f of x. Okay? So it's not symmetric. What is left? After I graph, I will identify the range. So now I'm here. This is what I'm working on, the last step before I graph. Okay. Here's a question. I will give you the shortcut and the recipe if you want, but I would like to talk about this. 2x minus 4 divided by x plus 2. Before we look at this, imagine that I have a cake. I purchase a cake tomorrow morning. And I want to divide it and give a piece to everybody in the state of Maryland. So x approaches a big number. When I get to your door, how much will you get? Not a lot. Well, I will say almost 0 because I divide by a big number. I don't know exactly how many people live in Maryland, but several million for sure. Only Baltimore has 600,000 people, right? So if I have one cake and I want to divide it up so I can give everyone, how much will you get? Because I divided one cake into a big number of people, right? So it's almost 0. So keep that in mind for a second. Now let's go back to our function. This is our function, 2x minus 4 over x plus 2. So tell me the degree of the top. 1. So I'm going to factor out x. Please tell me the degree of the bottom. I'm going to factor out x. Now please tell me how many terms are left. Remember, I cannot invent things. So if I start with 2 terms, I have to have 2 terms. X times this has to give me 2x, and this x times this has to give me -4, and the same thing at the bottom. So what should I write in parentheses right here? 2 minus 2. But if I put 2 here, x times 2 is 4. No.
No, that's
4 over x.
Thank you. So x times 2 is 2x. X over 1 times 4 over x is -4. What about the denominator? Very good. Awesome. That's it. Is that true? Yes. X times 1 is x. X over 1 times 2 over x is 2. I'm going to simplify. Based on what we just discussed a minute ago, I'm interested to know what happens when, we're talking about end behavior, what happens when x increases without bound, gets very large, like in my example here. Where does this go? Let's say now I have 4 cakes, but x is 2 million. How much will you get from my cake when I get to your door?
Sugar.
Not even sugar. Correct. So now I have 2 cakes, but I want to give a piece to everybody in Maryland. How much will you get? Yes. So then where does this whole thing go? Look at what is left and tell me what I should write. There is a 2 in there that I cannot change and I cannot make it 0. And there is a 1 in here. That's why I said look carefully. See what is left. This is 1 and 1. This is 0. This is 0. But I have a 2 and I have a 1. I can't change those. 2 over 1. 2. So this is the end behavior. What does this mean? It means this. That there is a line that is y equals 2. That eventually, at infinity, not in the middle, I don't care what happens here, but at infinities, the function will get closer and closer, closer and closer to 2. Maybe from above or maybe from below. That part I don't know yet. On the other side, at positive infinity, the function will approach 2 as x approaches infinity. Either from above 2 or maybe from below 2. I don't know. We'll establish that in a minute. This line is called a horizontal asymptote because eventually the function approaches that number. So then y equals 2 is a horizontal asymptote. Any questions? Now I'm going to try to make sense of my chart. see if we can figure this one out. Okay. From approaching 2, the function must increase because on the left-hand side of the vertical asymptote, it will go to infinity. Let this piece. From approaching 2, it increases to positive infinity on the left-hand side of the vertical asymptote. Here, it's starting at negative infinity, crossing the y-axis at 0, -2, crossing the x-axis at 2, 0, and approaching 2 eventually. One more time, the left-hand side of the vertical asymptote. From negative infinity, crossing the y-axis at 0, -2, crossing the x-axis at 2, 0, and increasing towards 2. So, all I need is my chart to put this in writing or put it in together in a graph. When we graph functions with asymptotes, what do you think we have to graph first? The asymptotes. When we graph functions with asymptotes, horizontal, vertical, it doesn't matter. This is the first step we have to perform. We have to graph the asymptotes. How many asymptotes does this function have? 2 asymptotes. A vertical asymptote at -2 and a horizontal asymptote at 2. Awesome. So here is -2. And here is the horizontal asymptote at 2. They are not part of the graph, which means I cannot graph them as solid lines. Okay. Again, let's go back to our chart and see what happens here. Okay. From approaching 2, above the horizontal asymptote, it goes to positive infinity. As expected, it will do this. Doesn't touch this, doesn't touch that. I have to plot 0, -2. I have to plot 2, 0. And the function says to me, the chart says to me, it's coming from negative infinity. It's crossing the y-axis. It's crossing the x-axis, and then approaches 2 from below. This is the graph of the rational function 2x - 4 over x + 2. Let's do this with the graphing calculator as well. So in y equals, clear whatever else you have in there. Put parentheses around the top, mandatory. 2x - 4, close the parenthesis and divide by x + 2. What other function we have to put in the graphing calculator? What is the other function that we already graphed and the calculator will not do it without putting it in? Which other function?
Asymptotes.
Of course, not the vertical one because there is y equals only, but the horizontal one, which was
-2.
careful.
Positive.
Good. So I will choose the viewing window as the standard. Here it comes. And now the horizontal asymptote. So as expected, it's coming from above 2, approaching 2, going to positive infinity on the left-hand side of the vertical asymptote. On the other side, it's coming from negative infinity, crossing the y-axis, crossing the x-axis, and approaching 2 as x goes to infinity. This is our type 1. Any questions? Any questions?
I think my things are wrong because I put in the exact same thing that you just put, but my
Forgot to put the division symbol. So it grabbed something totally different. It grabbed the quadratic function.
got it.
Can you just go back to your notes so I can?
Yes, of course.
And can I just see the other page?
Yes, of course.
Thank you.
You do not have to do this when you determine the y, the horizontal asymptote. I just didn't want to say to you, it's this, without showing you why.
Okay.
So there is a shortcut, only for type 1. Okay. For type 1, which means the same degree, same degree. Okay. The horizontal asymptote is y equals leading coefficient over leading coefficient, only for type 1. So if we go back to our function, here's the function. What is the leading coefficient of the top? And remember, it has to be presented in descending order. If it's not in descending order, you cannot identify correctly. So what is the leading coefficient of the top? What is the leading coefficient of the bottom? How much is 2 over 1? 2. And that is the horizontal asymptote. That's the shortcut only for type 1. And this is what we got from our analysis, which makes sense. I don't like just giving you pieces of information to memorize. So I wanted to show you how we get to that 2. Analyzing that 1 over x will always get to 0 as x goes to big numbers. Other questions?
Wait, can you explain that one more time? I'm sorry.
Yeah, which one? Here?
Yeah, how you just do it by looking at the leading coefficient.
Leading coefficient 2, leading coefficient 1, 2 over 1 is 2.
Oh, okay.
That's the shortcut. But again, I wanted to show you why and how we get to that. But you don't have to mimic that. It's just, I wanted to show you. Moving on to type 2. Yes? Type 2 is easier than type 1. So here's an example. Let's say x divided by x squared minus 1. What type is this? Is it type 1, type 2, or type 3? Yes, because the degree in the denominator is bigger than the degree of the numerator. We don't care by how much bigger. Okay. What do you think will happen here for this function concerning the horizontal asymptote? What do you think will be? Before you say anything, let me guide you. As x increases without bound, goes to infinity, a big number, which of these two, top or bottom, will be the biggest? Right. The bottom will be very big. The top, even if it's infinity, will still be smaller, much smaller than the bottom. So then every time I have one cake and I want to divvy up by 1,000,000, where will that go? Go to nothing. Very good. And that is the horizontal asymptote and the end behavior for all type 2. Okay? 0. Small divided by big. So f of x, 0, 0, y equals 0 is a horizontal asymptote for all type 2. Always. Because at infinities, the bottom grows so much faster than the top that the answer will be 0. Or approaching 0 to be exact. Good. Okay. How do I start? The rest is the same. Absolutely the same. So where do I start? What do I have to do first quickly? Yes, but I have to factor, right? I cannot identify the domain without factoring the denominator. Good. How do I factor a denominator? Very good. X minus 1, x plus 1. Now I can identify the domain. Can anyone give us the domain of this function? Anyone? Say it again. Your jump?
-1 to 1.
Exactly. Awesome. Very good. So -1, 0, 1, nothing here. Nothing here. Oh, I forgot. I want to come back here. I would like someone to identify the range. Because we have the graph. Can anyone identify the range for this function? Yes. Negative infinity to 2. Exactly. Very good. Awesome. That's the range. Well done. Good. Because it's everything except 2. Good. Awesome. Good. So I identified that x minus 1, x plus 1. Is there any way I can simplify this function? The answer is no, I cannot simplify it. X minus 1, there is no x minus 1 at the top. X plus 1, there is no x plus 1 that I could simplify. No one can simplify this function any further. Good. So then, if x minus 1 and x plus 1 stay in the denominator as factors, and I know that that's what I'm getting at. I'm trying to answer your question. What do I conclude about x equals negative 1? Right here on the chart, in the chart filling up. What do I write? VA. What do I write for x equals 1? That's it. Once you say that, then you'll have to say this immediately. One thing we don't know, though. What don't we know about the behavior left and right? The signs. I don't know if it's this, this, or this. Good. I will be using numbers as close as I can to those numbers, but I will not plot those. I'm just going to use them to identify the sign. Like negative 1.1, negative 0.9, and 0.9 and 1.1. This function is symmetric, and we will talk about it in a minute. Okay, so I plug in negative 1.1. The top, the sign. When I plug in x, negative 1.1, the sign of the top. In x, I plug in negative 1.1. So what is the sign? Perfect. Now the bottom, negative 1.1 minus 1. Negative 1.1 plus 1. 3 negatives. What is the sign?
Negative.
Thank you. Negative 0.9, the sign of the top. Negative 0.9 minus 1. Awesome. Negative 0.9 plus 1. Very good. So negative over negative. Very good. Perfect. With 0.9. 0.9 in x, sign. Perfect. 0.9 minus 1.
Negative.
0.9 plus 1. 1 negative.
Negative.
Awesome. Last one, 1.1. 1.1. 1.1 minus 1.
Positive.
Awesome. And 1.1 plus 1,
Positive.
positive. All positives?
Positive.
Look how quickly we advance this time. We have the domain. We will talk about symmetry in a minute. We know the vertical asymptotes. We know the behavior. We know the horizontal asymptote. We know the end behavior already. So I need just the x and y-intercepts. Okay. So when x is 0, how much is f?
Minus
0 at the top over negative 1 means
1.
0. That is the x and the y-intercept. There is nothing else. Now, I would like to talk about symmetry before we graph. So I have to find, if you remember, f of negative x. The top is negative x. The bottom does not change, stays at x squared minus 1. So this is negative x over x squared minus 1, which is the opposite of f of x. What type of function is this? when f of negative x equals negative f of x? It cannot be even because it's exactly symmetry with respect to the origin. So this is an odd function. Okay, let's look at the chart, try to make sense of it, and let's graph it. Okay, please follow me. From approaching 0, because it's going to negative infinity, it's under 0. From approaching 0 to negative infinity. From positive infinity, crossing at the origin, and going to negative infinity. On the other side, from positive infinity, approaching 0 from above. One more time. From below 0, coming down to negative infinity. On the left-hand side of the first vertical asymptote. On the other side, from positive infinity, crossing at the origin, going down to negative infinity. And on the right-hand side of the last vertical asymptote, from positive infinity, approaching 0 from above. When we graph functions with asymptotes, what do we have to graph first? The asymptotes mandatory. That's the first step. Very good. I know I sound like a broken record. Forgive me. Okay, so how many asymptotes do we have to graph here? Careful. Yes, but actually you are also correct because this is an overkill. It's the x-axis. But I will graph it so I don't forget. X equals 1 and x equals negative 1. I want to write a note before we continue. Here's the question. Can a function cross a vertical asymptote? No, ever. It's undefined. Right. Can a function cross a horizontal asymptote? Yes. Why? Let me explain why. Why I have to graph the line as the entire line. But actually, the horizontal asymptote only says that the function here approaches 0 and here approaches 0. Who cares what does in the middle? Right? That's not the end behavior. In the middle, it can cross the x, the y, the horizontal asymptote. It doesn't matter. The horizontal asymptote only tells us that at the very far end, it approaches a number, and at the very far this end approaches a number. So yes, we'll write a note. The vertical asymptote, the function can never cross a horizontal one, and a slant, yes. So note, a rational function can cross a horizontal asymptote, I'll put in parentheses, or slant. I'm going to talk about that in a minute. Comma, but never what? Very good. Never a VA. It can cross a horizontal, it can cross a slant, but it can never cross a vertical. Awesome. So now we are ready to graph. I will plot 0, 0. And then I'll do exactly what I just did. Here it is. From approaching 0 down to negative infinity. On the left-hand side of the vertical asymptote. On the other side, from positive infinity, crossing at the origin and going towards negative infinity. Crossing at the origin and going to negative infinity. Last portion, from positive infinity to 0. Can anyone establish the range of this function before we look at it using the graphing calculator? Yes, you can. Everyone can. Yes?
Negative infinity to negative 1.
Just cross it with horizontal lines. All possible horizontal lines will hit the graph of the function somewhere at any point in time or not.
Yes.
Yes. Once I say yes, then the range must be That's it. No matter where you cross it, the function, the horizontal line would hit the function somewhere. Very good. Any questions for me? I would like to graph one more before we look at type 3. I would like to graph one more. And you'll tell me which type it is. Okay, here's a function. And I would like you to tell me what type it is. We only discussed type 1 and type 2. So I specifically said this is not type 3. I just want to practice with one more example. So which type is it? If you said 2, if you say 2, it means that the bottom is much bigger than the top in degree. Is that the case? It's type 1. Why? The degree of the top is exactly 2, and the degree of the bottom is 2, right? So it is type 1. Perfect. Which means that the horizontal asymptote will not be 0. Perfect. Will not be 0. Only for type 2 the horizontal asymptote is 0. Perfect. Awesome. Very good. So here's my chart. But what is the first thing I have to do before I even get the chart going? Say it again. Factor. The key word is factor. Good. So can anyone factor the top for us? Awesome. X minus 2. Right. I'm going to have to change this. Oh, no. I don't want to change anything. Sorry about that. Okay. Perfect. I don't want to change anything. So here's the question for you. What restrictions on X will you write? What can X not be?
30.
X cannot be -3 or 1. Do you agree with that?
Yeah.
Perfect. So when I write the domain, I would write -∞, -3, 0, 1, infinity, and I don't have anything to write under these two numbers. Would you agree? Acceptable? Perfect. So I establish a domain by writing this and also putting in the chart like that. But now I look at the function again and I'll say, wait a minute. There is something I can do here. What am I referring to? I'm referring to the fact that I can simplify the function. How? Exactly. It's a common factor that goes away. Awesome. And then the final simplified form of this function would be over x minus 1. Awesome. Very good. So as you notice, one of these two factors in the denominator goes away, which is x plus 3. So do you think I am going to write in here in my chart up under x equals -3, will I write a VA? The answer is no, because the factor had disappeared with a factor from the top. What's going to happen in there? It's not going to be a vertical asymptote, but a hole in the graph. The function is still undefined because I'm not graphing this. No, I'm graphing the original function that is still undefined at -3, even if it does not have a vertical asymptote there, and it will not. However, since x equals 1 stays in the denominator, what will I say about x equals 1? If it stays, doesn't go away, that is the VA for sure. Very good. So for this one, I will write this because it's a VA. But here, what will I write left and right? Here's what I write. I replace x by -3 here. The top is -3 minus 2, and the bottom is -3 minus 1. So what is the top? -5. What is the bottom? -4. So this is 5/4. I replace -3 in the simplified form of the function. And that will be an open point. What open point? -3 comma 5/4. There will be a hole in the graph where that factor disappeared. Okay, any questions? Any questions? Okay, I want the x-intercept. When is this fraction or function 0? When is any fraction 0? A fraction is 0 when? When the top is 0. When is this 0? When x is 2. Very good. Careful where we put 2. That's very important. Everything has to be in ascending order. Perfect. And now I want to find when x is 0. When x is 0, either here or here, it doesn't matter. When x is 0 is 2. Good. What do you think about the end behavior? Last thing before we graph it. What is the end behavior for type 1? What is the leading coefficient?
Put it open upwards.
1, the leading coefficient. 1, the leading coefficient of the bottom. 1/1. That's the horizontal asymptote. Y equals 1, horizontal asymptote. This is it. Let's try and make sense of the information we have here. Ready? From approaching 1, it's coming from 1 to 5/4, right? So it's going up. 5/4 is more than 1. So from 1, going up to the point, through the open point, -3, 5/4. Going up, crossing the y-axis at 0, 2, and going to infinity on the left-hand side of 1. One more time. From approaching 1, increasing, going through the open point, -3, 5/4, crossing the y-axis at 0, 2, and going towards infinity on the left-hand side of the vertical asymptote. On the other side, okay, 0.9, 1.1. Okay, with 0.9, 0.9 minus 2, negative. 0.9 minus 1, positive. 1.1, 1.1 minus 2, negative, positive. I have to establish that before I even talk.
0.9 minus 1 is negative.
0.9 minus,
Be negative over
but it's negative over negative, which is positive. And then here I have 1.1, which is negative over positive, which is negative. Okay, coming back. So from 1, increasing, going through the point -3, 5/4, crossing the y-axis at 0, 2, going to positive infinity. On the other side, coming from negative infinity, crossing the x-axis at 2, 0, and approaching 1 from below.
Wouldn't that 1.1 minus 1 still be positive? Shouldn't both
Which
be
one?
Positive.
Which one am I looking at?
Just looking at the 1.1.
So the second half of it, the
Second half
1.1.
of it.
This one?
Yeah,
The
the
1.1 minus 2.
So we are talking about this side? Are we talking about this side?
Yeah.
From negative infinity,
Mhm.
crossing the x-axis at 2, 0, and approaching 1 from below. Was that the question?
I'm fine.
But did I answer your question?
No, I was just, I was just trying to keep up with the math of when you were calculating the 1.1 and the.
Oh, yeah. Let's do that one more time, okay? Let's do it one more time with 0.9, correct?
Mhm.
So 0.9 minus 2 is negative. 0.9 minus 1 is also negative. That's why this side is positive.
Mhm.
Now with 1.1, 1.1 minus 2 is negative, but 1.1 minus 1 is positive.
Okay.
Now, we will be able to catch all mistakes very quickly. Because if this side is positive, there is no way it crosses it to 0. It has to come back and cross again to come back to 1.
Okay.
So I will catch my mistake immediately. One more time. So if I write here positive, it has to cross it to 0, but then it has to turn around. It has to cross again because it has to come up closer and closer to 1. But I only found one x-intercept. So it cannot cross again.
Okay.
Does it make sense?
Yeah.
Okay. Good. So let's graph. What do we graph first when we're asked to graph a function with asymptotes? Yep. Have to graph the asymptotes first.